Excellencies, ladies and gentlemen, I'm very happy to be here today. My name is Therese Hindman Persson and I'm Chief Economist at the Swedish Energy Markets Inspectorate. Sweden is co-lead in the Power System Flexibility campaign, and together with the IEA, we hosted a workshop on market design and flexibility last year in Paris. For that workshop, we commissioned a state-of-the-art review of demand-side flexibility that formed the starting point for our discussions. We had indeed very fruitful, constructive discussions in Paris physically last year, very different from this year. It was clear that there is not one market design that fits all or can be seen as superior to others when it comes to promoting demand-side flexibility. Rather, international collaboration and learning is key to unlocking the full potential of flexibility. Climate change is a battle we all need to fight, and clean energy transition is the path forward. As you are all aware, I think, Sweden has come very far when it comes to renewable energy generation, and we are well underway when it comes to energy transition. However, in order to accelerate further when it comes to reaching net zero emissions, we need to move even faster when it comes to exploiting flexibility resources for the good of all. Such flexibility resources can come from many different sources. It could be demand-side flexibility, which we see as a largely untapped resource. But it could also be various storage solutions, it could be different types of flexible production, and it could also, of course, be hydrogen. We see also that we need a whole systems approach. Several different sectors need to be involved. Power sector, of course, but we need to maybe consider the role of various actors and the role of grids in new and slightly different ways going forward. But we also need to work closely with transportation sectors, with industry and other actors. So it's a whole systems approach going forward. We see that market design for power systems with high penetration of variable renewable energy is key to explore further. We need international collaboration and learning, and we need to find ways that we maybe didn't even see or consider a few years ago. We need to investigate and analyze further regulatory options for integration of new technologies. And we also need to look at how we can transform existing technologies and regulations, of course, going forward. So from a Swedish perspective, we see flexibility as an integral part of a sustainable energy future, and we see international collaboration and learning as key going forward. I cannot emphasize that enough, I think, because we think there are so many things going on all around the world, and we need to have a close collaboration. So I'm looking forward to a continued collaboration on these issues, and I'm sure we will meet again, both digitally but also physically when that becomes possible. Thank you very much.
Chile has been recognized as the leader of the emerging economies for the development of renewable energy. But increase our renewable share does come with great challenges. One of the big questions is how to manage a high share of renewable resources such as solar and wind, considering that our current goal is to achieve at least 70% of renewable generation by 2030. And the most common answer is flexibility. But this is not only an issue for us, but for several countries it's now critical to have flexible power grids that allows them to integrate more viable renewable resources without compromising the security, efficiency, and reliability of the system. In that sense, this is a global problem which demands a global and coordinated solution. That's why Chile has been part of the Power System Flexibility Campaign of the Clean Energy Ministerial, because this instant has been a great opportunity to share experiences and learn some lessons from other countries about how they are dealing with this new challenge. In different workshops and events of the campaign, Chile actively participated, showing how we have been able to reach our renewable goals, and we have seen how other countries implemented different solutions, not only to promote the development of new flexible technologies and solutions, but also how to use flexibility from other existing facilities. In that sense, in Chile as well as in California, we already have proven some real solutions. For example, we successfully tested a solar photovoltaic power plant providing ancillary services, which is a major breakthrough to address the future needs of flexibility. In addition, being part of the campaign has been a great support for the development of our public policy. In 2019, we proposed the development of a flexibility strategy to define the roadmap of action needed to have market signals and appropriate processes that enhance the development and use of flexibility in the Chilean power system, while keeping in mind that flexibility is not the goal, but a tool to achieve a secure, efficient, and sustainable development. In order to build that strategy, we had a strong collaboration from the campaign, especially from the International Energy Agency as the operating agent of the campaign, including them into the different participation and analysis processes that allow us to publish our strategy in September 2020.
The flexibility strategy was developed by the Ministry of Energy with the collaboration of the National Energy Commission, the market regulator, National Electrical Coordinator, this is the ISO of our system, and Expert Advisory Commission specially conformed for this instance, and of course the collaboration of the International Energy Agency. In addition, different antecedents were considered, including previous studies and analysis carried out for this strategy. On the other hand, a working group was set up including representatives of the universities, consultants, and energy sector in general, in order to know the different points of view and proposals of the stakeholders. The strategy defines a roadmap with 13 months period that comprises 3 main lines of action. Number 1, market design for the development of the flexible electricity system. Number 2, regulatory framework for the storage system and new flexible technology. And number 3, flexible operation of the power system. In the first one, the strategy defines the several measures for the market design, such as improving the adequacy market and establish signals to encourage investment in technology that provide flexibility. In fact, currently we are working in this activity and we are proposing a new regulation to implement these measures. In the second one, there are regulatory proposals to enhance the role of the storage in the operation of the power system and the transmission planning. Finally, in the third one, there are measures for the flexible operation of the system, including improvement in the marginal cost signal, the unit commitment process, and real-time operation. Therefore, we hope that this initiative contribute to achieve our goal of the secure, efficient, and sustainable development by promoting investment in facility that supports a flexible system.
Our world is facing a major health crisis, but this shouldn't take us apart but bring us together. We need to enhance and reinforce every collaboration instance as the Clean Energy Ministerial with its campaign and initiatives, as well as the mission innovation. Join us to face together the challenge of flexible power systems.
We are taking up this addition of renewable energy, which is going to touch 175 gigawatt by the year 2022 and about 450 gigawatt, minimum 450 gigawatt by the year 2030. In the year 2030, as per our optimal generation mix model that has been prepared by our agency, our total installed capacity is going to be about 816 gigawatt. Out of that, only 267 gigawatt capacity will be there from the coal-based power plant. The share of coal-based power plant is going to be reduced in terms of installed capacity about less than 40%. But for balancing the grid and with the renewable energy injection, we need to have a lot of flexibility of our coal-based power plant, and we are vigorously following up with our thermal plants because they'll have to back down when renewable energy in the daytime. When renewable energy is coming up on large scale, we'll have to back down our coal-based thermal power plant, and we have to use them during the peak hour, during the night period. For that, flexibility of our resources is really a very important issue, and we are working in technical collaboration with Germany, with USA and Japan.
So it is not uncommon in the grid right now to have a variation of 20 to 30 gigawatt during the day, and we are increasing at the rate of 5 to 7 gigawatt per annum is the increase in the variation. So this is a major area of concern for us, both for the thermal generators as well as for the grid operators. How do you maintain the grid stability with such large renewable penetration to the grid? And since all our units were initially designed for the baseload operation, we need to take some modifications, do some modifications so that they can be made ready for the flexible operation.
In order to make Indian thermal power plants flexible, the Indo-German Energy Forum initiated a flexibility program. This program aims at showcasing the technical feasibility of the flexible power plant operation. Test runs at various power plants are at the heart of the activities. A test run at NTPC's Dadri power plant with 40% minimum load operation formed one milestone so far. Currently, we are preparing a test run at the 500 megawatt unit of the Maiton power plant, which is operated by Tata Power.
The technical feasibility has been proven, but sadly I have to admit the hard part is still ahead of us. And one important aspect which remains to be solved is the economic viability. Another important task ahead is to bring all those thousands of plant operators in this country on the same page. Some are already in, but trainings on simulators are required, trainings as such in operating these plants is required, and as of now, baseload operators have to become expert in flexibility. And we would propose to call them flexperts. If these tasks which lay ahead of us, which require combined effort of the ministry, NTPC, and all the Indian leaders in power plants operations, the state operators and generators, but also the power plant associations like EEC, and development agencies like USAID and ourselves, GIZ, to reach out to the operators of these plants.
Hello, my name is Renato Haddad, and I work at EP, the Brazilian Energy Research Office, related to the Ministry of Mines and Energy and responsible for energy planning studies and national energy statistics. I'm glad to speak about our involvement in the Power System Flexibility Campaign under the same framework because it has provided very useful insights for the development of several studies and works led by EP, having had a clear and positive impact on the elaboration of Brazil's energy expansion plans, as well as contributing to the process of modernizing the regulatory framework of Brazilian power system. Brazil's power system has a large interconnected grid and a majority of hydropower generation, around 65% of total supply in 2020, what put us in a very special condition in terms of operational flexibility. However, market rules and the regulation of the various sectors involved must be attentive and encourage the use of this valuable resource in the best possible way. It was in this context that we shared our challenge with the other members of the PSF campaign in the event held in Paris, February 2019. The benefits of this participation were immediate. Our presentation began several conversations afterwards, stimulating a debate and better understanding not only about our hydroelectric resource, but also about technological opportunities that had not yet been explored in Brazil, such as demand-side management. The Brazilian 10-year plan 2029, prepared in 2019, for the first time considered in a sensitive scenario, demand response as an alternative for meeting capacity requirements. This kind of energy planning improvements demonstrate in a straightforward way the practical value of the PSF campaign and how it can deliver results that shape energy sector transformation. In partnership with the IEA, we developed the technical workshop Brazilian Power System Transformation in November 2019, which counted on the participation of local and international partners. Opportunities and challenges were discussed regarding operational and regulatory aspects of demand response, in addition to the importance of digitalization for the efficiency of this process. In 2020, the discussions and advance focused on key demand-side aspects and also exchanging experience on how countries have modernized their markets to address flexibility needs. The modernization of the power sector is a complex task, but one that needs to be faced. The challenge increases when we talk about a grid of continental dimensions with vast and diversified renewable resource and an emerging economy, as is the case of Brazil. EPE, together with the Ministry of Mines and Energy and other institutions in Brazil, have pursued the implementation of a more efficient markets and regulation, which induce the adoption of the state-of-the-art in terms of technologies and business models to provide reliability to the power system. We are certain that looking at the flexibility in the power system in a broad and integrated way is a fundamental step towards achieving this goal. Being part of PSF campaign has supported us in moving forward in this agenda. Thank you.
My name is Andreas Feldmuller, and I'm responsible for expanded scope solutions in the power plant service organization of Siemens Energy. Let me summarize our participation in the campaign, which started in 2017 with the title Advanced Power Plant Flexibility Campaign. I had the honor to represent the energy businesses of Siemens in the campaign and to coordinate the contributions of our company, as our Flex Power Services portfolio is part of my responsibilities. Until CEM9 in May 2018, the focus of the campaign was the flexibility of power plants to allow the use of all volatile renewable energy in the power system. Flexible plants as the perfect partner of volatile wind and solar power. Many stakeholders were unaware of the solutions for enhanced power plant flexibility and the benefits for plants and the power systems. We were able to present plant capabilities in general, as well as convincing showcase examples for most flexible plant operation which were included in the report of the campaign. The biggest advantage of the Flex Power Services portfolio is the possibility to improve the flexibility of existing plants with these service plant modernizations. At CEM9, the Power System Flexibility Campaign was launched as continuation of the Advanced Power Plant Flexibility Campaign by widening the scope to include smart electricity grids, storage, and demand-side management. We could contribute to these topics as well, but the flexibility of power plants was and will for a foreseeable future be an important part and an important lever to increase the percentage of renewable power generation as well as to ensure grid stability in the power systems. We have further developed our Flex Power Services portfolio, and I have asked our key expert, Matthias Nickl, to show you what can be achieved by utilizing state-of-the-art start and stop features in combined cycle power plants.
Thank you, Andreas, and also welcome from my side. My name is Matthias Nickl, and as Andreas mentioned, I will show you within the next minutes 3 showcases of power plant flex upgrades and how they contribute into overall power system flexibility. Last but not least, which kind of improvements we can achieve. On the next slide, you see now an overview of several of our upgrades, all targeting the shortening of startup and shutdown durations of the power plant, allowing the fast reaction on changing power demands in the grid. How does it work? First of all, let's have a look at our hot start on the fly, targeting on the optimization of hot restart of the power plant. We are working here on a full automatic, non-hardware related feature, which allows to change from a sequential startup concept, you can see it in the diagram here, where the gas turbine is started up, hold on a lower load, waiting for the startup of the steam turbine, and can now changing over the whole process into an unrestricted start of the gas turbine, whereas our steam turbine will then be started up and loaded in parallel of the gas turbine loading to higher loads or even base load condition. With that approach, we can minimize startup duration and also fuel consumption during this transient operation. Means, in other words, we have an optimized concept to improve reaction of the power plant in the startup phase, reacting on grid demands as fast as possible. But of course, this is not only interesting for hot start conditions, as we see changes in the current operation procedure from a lot of hot start demands, even to extended shutdowns, as the ingress of the renewables is coming in more and more also for extended time durations. We recently finalized and implemented our so-called warm start on the fly, targeting the same approach to minimize inefficient or low efficient load holds of the gas turbine during the startup procedure, allowing a nearly parallel loading of gas and steam turbine in the whole startup process, with the same result to achieve the fastest and most efficient and economic startup for the power plant, having the best possible ingress answer on the renewable fluctuations. And last but not least, of course, we can also offer to do the same for the shutdown of the plant, as it's of course also important not be only fast at the grid, but in the meantime also react fast and efficient on renewable ingress in the demand time of the day by also shutting down the power plant very fast. And how we're doing this is quite the same strategy like I explained and showed in the beginning for our startup products, There we can also optimize the concept like this, that we will minimize insufficient and time-consuming load holes of the gas turbine by doing full automatic and also software-based changes, and we can achieve with this a nearly undisturbed and fastest one-time shutdown of the complete powertrain, which leads also to an absolutely competitive, flexible operation behavior. Means the combined cycle power plants will support as much as possible the energy transition for the upcoming renewable ingress. With that explained, please let's have a look back to the overview from Andreas.
Thank you very much, Matthias, for these technical insights, looking at 3 examples of the Flex Power Services portfolio, which covers many more products to improve all aspects of power plant operational flexibility. Looking back at the years of the campaign, it is obvious that the speed of the energy transition has globally grown remarkably. Many countries started to expand their energy transition, formulating decarbonization targets for the years to come. My company, Siemens, carved out the energy business, and Siemens Energy is now an independent company with a purpose to energize society. Car manufacturers step away from building the most powerful fossil-fired engines, now starting battery factories and designing electric cars, which in fact increases the demand side of the power sector and the need for renewable energy. We were able to present the importance of the sector coupling during the campaign, and surplus renewable energy will be more and more converted to hydrogen, power to X, or heat, helping to decarbonize other sectors like industry and mobility. Having the goal of net zero CO2 in mind, fossil fuels need to be replaced by renewable energy or by green fuels produced with renewable energy. Green hydrogen for generation and sector coupling is a key element on the agenda of Siemens Energy. And we are in an excellent position to help companies and societies on the path of decarbonization. Thank you very much for your attention.